Hello once again and welcome to today's chemistry class for S.S.1. In today's class, we're going to be looking at acids. But before we proceed, I would like to tickle your fancy a bit. A neutron walks into a pharmacy and asks how much for a tablet. The tender replies, "For you, no charge." You get the drift? Remember that neutrons have no charge. And so today, what are our lesson objectives? At the end of this lesson, the students should be able to define an acid, differentiate between a strong acid and a weak acid, differentiate between a concentrated acid and a dilute acid, mention uses of acids. So going forward, what is an acid? An acid is a substance which produces hydrogen ions or protons as the only positive ions when dissolved in water. Acids dissolve in water to produce hydrogen ions as the only positive ions together with the corresponding negative ions. This process is known as ionization. There are two classes of acids. Inorganic acids. They are generally strong in nature. A good example is H2SO4 and HNO3. And then we also have the organic acids. They are generally weak in nature. Example is ethanoic acid and citric acid. Now, acids can be concentrated or dilute. By this, we mean that a concentrated acid is one that has little or no water in it, while a dilute acid is one that has little acid and a lot of water in it. Acids can also be strong or weak. A strong acid is an acid that ionizes completely in solution to produce a lot of hydrogen ions, while a weak acid is an acid that ionizes partially in solution to produce few hydrogen ions. Now, don't make a mistake. Strong acids and weak acids can also be dilute or concentrated. Now, for emphasis, I have just told you that a strong acid can be concentrated or dilute, while a weak acid can also be concentrated or dilute. What makes an acid strong or weak is its ability to ionize and produce hydrogen ions. The higher the level of ionization, the stronger the acid. So now let's take a quick rundown of the difference between organic and inorganic acids. Organic acids contain carbon, and inorganic acids necessarily do not contain carbon. Generally, organic acids are weaker acids than inorganic acids. In fact, organic acids are even edible, like the ones you find in your oranges, your fruits, and all those. Most of the organic acids are insoluble in water, sometimes miscible with water, but soluble in organic solvents. But inorganic acids are generally well soluble in water and non-soluble in organic solvents. Organic acids have a biological origin, whereas inorganic acids haven't. Inorganic acids are derived from inorganic compounds or mineral sources, invariably meaning they are mostly produced in the lab, unlike the organic acids that are produced in nature. Mineral acids are highly reactive with metals. They have corrosive ability than the organic acids. Essentially, the inorganic acids are more harsh and corrosive compared to the organic acids, which I told you earlier on are even edible. Going forward, let's look at the properties of acids. They have sour taste, like the ones you have I mentioned earlier on in all your fruits. All those sour taste you feel in those fruits are signs of organic acids. They turn blue litmus paper red. They liberate CO2 when they react with any triacylcarbonate 4. So anytime you hear that an acid is reacting with a triacylcarbonate 4, a gas will be given off. That gas is CO2 gas. They also liberate hydrogen when they react with metals. Acids have corrosive nature. Acids can conduct electricity, and they usually have a pH less than 7. Don't forget, pH means potential for hydrogen. They always have that pH of less than 7. Basicity of acids. Now, the basicity of an acid is the number of replaceable hydrogen ions in one molecule of an acid. There are 3 common types of basicity of an acid, and these are the monobasic, sometimes we say monoprotic, dibasic or diprotic, and then tribasic or triprotic. Now, the monobasic, as the name implies, means it can produce 1 hydrogen ion when dissolved in water, while dibasic can produce 2 and tribasic can produce 3. Preparation of acids. There are 4 methods which can be used to prepare acids. The first one is by dissolving an acid anhydride in water. Now, acid anhydrides are oxides of nonmetals which will react with water to form the corresponding acids. A good example, SO2. When you combine it with water, we get H2SO3, which is of course a weak acid. Another method of preparing acids is by dissolving a weaker or more volatile acid to form sodium or potassium salt using a stronger but less volatile acid. A good example, NaCl plus H2SO4, that will give us NaHSO4 plus HCl. A third method of preparing acids is by precipitating insoluble sulfides of metal from a solution of the metallic salt using hydrogen sulfide gas. And you have a good example of it on the slide. You can look at it very well. In the end, we have ethanoic acid that is prepared. And the last method is by direct combination of the elements. Of course, we take hydrogen, we take chlorine, when we mix them together, we get HCl. So let's now take a look at the uses of acids. Before you mention the uses of acids, please ensure you mention the type of acid and then what it is used for. The reason is there are different types of acids, and not all of them are used for the same thing. So vinegar, for example, is used in the kitchen, and it is a liquid that contains about 3 to 6% acetic acid. And if you eat any meat and you discover that the meat is very soft even to the bones, there's a very likelihood that it has been soaked in vinegar. It is used in pickles and in many food preparations. Now, nitric and sulfuric acids are used in the manufacture of fertilizers, dyes, paints, drugs, explosives. Now, any chemical that is used for a wide variety of purposes, we refer to such chemicals as heavy chemicals. Sulfuric acid is also used in batteries, which are used in cars, while tannic acid is used in the manufacture of ink and in leather making. Boric acid is a germicide and a mild antiseptic. It is used to make our germicides and antiseptics that we use in our toilets and bathrooms. Fatty acids are used in the manufacture of soaps through the process of saponification, while tartaric acid is used in the making of soda, soft drinks, and of course, health salts. Summary. In this lesson, you have learnt about acids, their preparation, their uses, their properties, etc. Time now for a quick assessment. Give an example of the following acids: monobasic acids, dibasic acids, and tribasic acids. 2. Mention 3 uses of acids. 3. Mention 3 properties of acids. And so with this, we have come to the end of this class. Thanks for watching and see you in the next class.